Welcome to your second lesson in section 9, chapter 9. This is section 2, and we are going to deal with some really fun graphs, and these are specific equations that you will need to be able to identify the type of graph from the equation. You will not have a calculator. I won't ask you to specifically draw these. You will in the lesson, but I believe on the assessments right now we're just going to have you match the equation with the graph. So I need you to be very familiar with them and with the nature and the characteristics of the graphs. So if you look at the paper that you see right now on the screen, I would like you to pause it and cut up the paper I gave you and get this laid out similarly. Write the 4 equations that I have down. And you will need 4 colors because I'm going to draw all 4 graphs on this picture, and I'll show you how similar they are. But I'm going to use the different colors, so get the different highlighters. I'll pause it and you come back. All right, so I'm going to start with what I have labeled over here as the circle. Now, if you remember from 9.1, I said that you had simple equations, and that was when it said r equals 3. Well, that means that you have a radius of 3, and the center is at the origin, or the center pole. So now I'm going to give you an equation that says r equals some value cosine theta or sine theta. And if it is cosine theta, I've highlighted what this particular graph is showing. This graph is showing you that that is an A equals a cosine theta, a positive. If it were negative cosine, it would be over on this side. If it was sine, where do you think it would be? It would be up above on the y-axis, and negative would be down here. So this is what you would think of as a circle, but notice where the center is. The center now is no longer at the pole. The center is half that distance on that axis. All right, but we have a diameter of 3. So I do come out to the 3rd ring. That's my diameter. So I'm going to write that down. The diameter is 3. And my center is at 1.50. Just so that you can kind of get an idea of how that nature is. Now let's look at a similar shape right here. If I have, all right, that would be a circle, but now I'm going to add a value to it. And what that does is it's called a limicon. And this has a 1 loop limicon. You can also have an inner loop limicon. And this is and a cardioid is a type of limicon. See how all these are similar. So this graph right here, I want to graph here. Let's graph the circle before we go on. So I'm going to have a radius or diameter of 3, and I'm going to have a center at 1.5. So I need to graph my circle right here. That's pretty good. That's pretty good. All right, so let me draw that in green so you can see that's the circle. Now this 1 loop limicon with the 3 in the front is going to give you the length is now going to be the sum of those 2 numbers. So here my length is 5, or the 3 plus 2, and it is symmetrical to the theta is 0. Well, my theta here, 0, that would be symmetrical to this axis. For the cosine is going to be on this axis. Now this particular graph, this one drawn right here, is a sine graph, and you notice that it's down below the axis. So this would be at the A minus B. Okay, so it's a minus graph and it's down below. This one, let's graph this. This would come out to 5. I'm going to switch to my pencil again. 3, 4, 5. And it's going to come in a little bit here, and it's going to come out, let's see, I think it comes here to -1. And then it comes out a little bit. It goes up to, let's see if I can sketch that out. That's pretty good. Okay. Here at this one. All right. Let's do the one loop. The one loop, if you notice, these numbers are reversed. I now have the larger number with the trig function. Okay? My length is still 5. So my length is still 5. I still have the 2 plus the 3. But here it has an inner loop of, whenever that number is greater, of 3 minus 2, an inner loop that is 1 unit long. So it's going to come in and it's going to loop around here. And it's still going to come out to 5. So, but if it starts here, let's see, 3, 4, 5, still comes out and goes around, still comes out, but it's going to loop like that. See, that's why I do these in pencil. All right, but I'm going to highlight that in orange so you see the loop. Okay. Now the cardioid is going to have a length of 6. Okay, the 3 plus 3, and it doesn't have a loop per se. Let's talk about this picture for a minute. This is a cosine because it's on the right and it's positive. It would be a sum. And this is also a cosine, but it's on the left, so it would be a difference. It would be negative. All right, this is a length of 6, so we're going to come all the way out to here, right? So we're coming out, we're coming back in like that. Let's see if I can get that in there. There you go. That's what we'll do. Okay, and it is also symmetrical to that center, that polar axis. Okay, let's do some more. We are now going to set up these down here, lemniscates. I'm probably mispronouncing that, but that's what this type of a graph is, and these are kind of fun to draw. I'm going to use my yellow here and kind of separate this. Okay, this is different type of graph. So this is one group. All right, this is the limicons are one group, and the circle and the cardioid. This is a different type of graph. All right, and these are fun. If you'll notice, you can tape this down and write in these equations. I think I'll use green on this one, and I'll use pink on this one. So this particular graph, this one's kind of fun. It looks like a figure 8 or a Mobius strip or an infinity sign for that matter, and it has a different nature. When you look at this particular one, this is the cosine one. So let's highlight that. This is the cosine one. If you also notice, these equations say r squared. They are the only ones, hint, 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 that have the r squared, that you know are going to do that. Everything else is just going to have an r. All right, it won't be r squared. So if it's r squared equals a cosine, let's do that one first because it's similar to this. Your petals essentially are going to be as long as the square root of that number. It's squared so you can remember that you're taking the square root. So the petal length is 3, or the square root of 9, if that helps. Okay? And you're going to, you can graph this on the calculator. I can show you how to do that. You have to change a lot of change the mode for one thing, and you have to change some of the settings. All right, but let's graph this. If we're coming out to 3 here, okay, you want to cross that's pretty good. All right, I'm going to make that in green. So, all right. Now, if you imagine if it was the sine equation, it would not be on this axis, but maybe it would be on the vertical axis. Okay, but it would be perfectly either horizontal or vertical, depending upon the sine or the cosine. All right, for this. No, I take that back. It's not. The sine is not vertical. I misspoke. Don't write that down. All right, the sine, which is like this one over here, it's not vertical. I think it angles. Let's graph that one. So this one also has a petal length of 4. Can't believe I just told you that wrong, but I did. Petal length is 4, or the square root of the 16. You can remember that, because this is the squared one. But this one is at an angle, and this one is symmetrical to pi over 4, the 45 degrees. So if I go up to 45 degrees, let's go through here. Okay, that is going to make 1, 2, 3, 4. That's going to be my middle line, so to speak. That one looks pretty good. All right, I'm going to make that in pink. There we go. Those are fun. I like those. And again, they're very easily identifiable because of the square. Okay? Now, I want you to think about it for a minute. If we had r squared equals 16 the sine of negative 2 pi, I want you to think about what would happen. And I'd like you to try graphing it and check out what happens. Now, it's a little tricky when you graph these. You have to change your mode to polar coordinates, and you have to graph the r equals the positive square root, and then you have to graph r equals the negative square root when you put those in, when you put the equations in. But then see what happens. Come back to class, or maybe try to graph it and see if you can make the graph go the other direction. The same thing over here with the cosine. If you had a negative cosine, negative 2 theta, for example, right here, see what you think that would do, and see if you can change the graph that way. All right, I'd like you to, we're going to stop here. I'm going to show you very quickly what you're going to set up for the next one. We are going to set this up so that we are going to draw these graphs. We'll do the roses next. So if you will get that ready, we will have that set up for the next video. See you then.